Hey everybody, Lars here again. Time for the second review video for Big Bad Unit 3. This one we kind of full stop with our regular programming things, and we are going to look at file I/O. I always tell the story when I do this video. I'm going to try to make this video a little quicker, but basically when I was a kid, back in the wild west 80s, they didn't know what they were doing when it came to teaching computer science. Yeah, we got intro, yeah, we got data structures, but after that it was kind of wild west. What they did back in the day was they threw a bazillion different programming languages at you. When I went to college, I took a class for COBOL, for RPG. It was an IPM report generator language. I took a class for PL1, which was C before there was C. Pascal, Fortran, Basic, blah, blah, blah. You go up and down the line, boom, boom, boom. And what they did was they taught you all of the things, pretty much all the things that we're going through right now. How to deal with simple data, iterating with for loops, doing, functions and modularity and things like that. But one thing that they always skipped over, which I thought was very odd, was file I/O. When I say I/O, I mean input and output. As far as dealing with files, because when you get in the real world, that's all you'll ever deal with. Your boss is not going to come up to you and say, do a for loop and create the first 300 natural numbers. Trust me, it's never going to happen. You're always going to be dealing with files, and files simply are just durable stores of data. You know how we do programs so that we can save our code and the next day just bring it back up? Well, files are just that, but with data. Okay? Or you could have a programming file or whatever. It's a durable store that you could hold on a hard drive or a memory stick or whatever, so that you save it to that device, and then 2 or 3 days later when you go back to retrieve it, it's sitting there. So whenever you deal with a programming language, you want to have a way to read from a data file and or write back out to a data file and handle things that way. And as I always do at this point in the video, is mention that this is my salute to all the people that were teaching me back in the 80s, because I don't know why they skip file I/O. And I always promised myself if I became a CS educator that I would not skip file I/O. So I'm not, and we're going to do it for the next 10 or 15 minutes. All right, I already whipped up some code for us. Let me put on my glasses. No, I don't want to see Camtasia. I want to see this. That's right. Okay, very simply, I have a file. That file I'm going to show you with Windows Explorer right here. I call it small e22, okay? And it's got names, and it doesn't really show it very well in Notepad. But small e22, the e22 I believe is because it is the file from Euler problem number 22. But I made it smaller. I think that was a really big file full of names, and this one is a smaller file full of names. So I have a file, and it has data. It's got names in double quotes separated by commas. So that's the data in that file. So what I want to do here is I want to read it in, and I want to get that data in a format where I can use it and I can look at the names. So the first thing I'm going to do right here is, you can see I set a variable name, and I assign it the string small e22.txt. Okay, that's the name of the file. This program right here resides in the same directory as that file, so I don't have to put a big path name. I can just, it will realize that it's relative, and this file should be in the same directory. Okay? Then I follow the 3 steps that we usually follow when we read in data. I'm going to open the file, I'm going to read from the file, and then I'm going to close the file. Back in the day, we always had to close our files, because if you didn't close the file, then somebody else couldn't come along and use it also. So I always say, be a good file citizen and close your file. It also keeps the file out there in memory, but these days we don't care as much about memory, because like I always say, we have tons of memory right now. So we're not worried about that reason, but we do want to close our files and be good file citizens. All right, so the first thing I'm going to do is I got my variable name, and it's the name of the file with a string. And what I do is I set a variable. Back in the day, we would call it a file handle. It's going to be the variable that we use to access the file, and I assign it the value of open, and in parens, the name of the file, which we did with a string, and then R. That R means read, for reading, okay? So then the next line, I create a variable called data, and I assign it the result of this. F dot, now we're doing this a little just in time. We're doing the object-oriented method way. When I get a file, I'm really getting a file object, and read is one of the methods that file has. So I'm going to read from it. And what that basically does is says take the entire contents of the file and stick it in data as a string, okay? Because we're reading what are called sequential files. We'll get into this later, and you don't have to worry about it right now. Right now, just realize we're reading a text file, and that's going to take all of the text in that file and put it in that string called data. And then what I'm going to do is I'm going to do f.close, and I'm going to close my file. So then I'm done with the file, right? Once you hit that close, you're done. No more file I/O, but you've read the data in. So then I'm going to print it. Let's print that out and see what it looks like. All right. Interesting, interesting, interesting. Now put that down there, make this readable so we can play around with it. No. All right, there we go. Okay. So as you can see over here, it's just basically took what we had in the file and printed it out. Okay. Now, what if I want to find out how many names are in there? Well, I'm really kind of skunked right now. Because if I did an len, okay, why was that there? No, that's okay. What I want to do really is I want to go down here. And if I run a len on the data, I get 2083. But does that mean there's 2083 names? Pregnant pause? Wow, do you figure that out for yourself? No, it doesn't, because I'm doing the len of a string. Data right now is a string, so I know I've got a string with 2083 characters. It's not necessarily that many names, okay? But I've got my data in a string. So what can I do with that? I think I know. I have some code whipped up for us. I'm going to show you. It's pretty cool. All right. Let me get rid of that. Let me push this down here. Don't worry about that. Never mind the man behind the curtain. I am the great and mighty Oz. All right, what we're going to do now is we have all of our data in a string, but what we really want to do is put it in a list. So we're going to do two things, and along this way, you're going to learn how to deal with comma-separated value files. The first thing I'm going to do is I'm going to take data, and I'm going to run replace on it. And as you can see from this little line right here, hopefully I'm zooming in nice and close when I do the production on this video. And you can see right here, I'm taking those double quotes and I'm replacing them with nothing. Boom, boom. Two single quotes is nothing. It basically means get rid of it. So that's going to get rid of all of the double quotes, and all you'll have is the name separated by a comma. Actually, I'm going to show you that when I run it. So watch. Now when I run the program, now it just does the names with the comma, see? Because I save it. Remember I told you that when you use methods on strings, it's not permanent? Well, this one is permanent because I saved it to data. All right? So then when I print data, you can see we get a name, comma separated. So now we do this. Data equals data.split. Do you remember the split method? It's very important because what split does is it takes a string and it breaks it up by whatever you give it here. This is called the delimiter. In this case, the delimiter is a comma, and we have commas separating all our names. So what split does is it takes a string, and every time it finds a comma, it creates a new item for a list. And the return item, or the return value from split, is a list. So now data is a list. And if we split by the comma, data is going to contain all of the names in that list. So now when we print data, we're going to have a list. And we do. See how they're in single quotes? They're strings in single quotes, but they begin here with a bracket. So we know we have a list. Okay? So now we started with a file, small e22.txt. The names were in quotes. They were separated by commas. We read them all into a string. Then we came down here. We replaced those double quotes with nothing, and we did a split by the comma. So now we have a list. And you might be saying, well, la-dee-da, it pretty much looks the same as it did before. We're not making any progress. And I would say, nonsense. We are making progress, because what can we do now? We have a list. We can iterate over that list because our names are individual items. Look at the stuff we shouldn't be looking at. Get out of there, kid. You bother me. All right, so now I'm going to print it there. We have something we can iterate over. So what am I going to do? I whipped up a little code here. I created a counter called C equals 0. And I say for I in data, no need to deal with range. I have a list. We iterate over lists in Python. That's what we do. We don't need range. I'm just going to go into data and look at every item. Okay? I'm going to click my counter. This, I'm going to make a note of it. C plus equals 1 is the same as C equals C plus 1, okay? It's just shorthand for clicking a counter. That basically means C equals C plus 1, all right? Then I'm going to see if the item in my list is equal to Elva. Elva is a name that I happen to know resides in this list, okay? I can't see it, and I'm not going to look, and I look before it, I don't find it. So if I find Elva, I'm going to print it, and then I'm going to print where I am with the counter so I can see where Elva is. Then I'm going to run through my whole list, and when I come out, I'm going to print the whole counter. Okay? And then we'll double check it. I'll do a len on data after we do that. So I'll make sure that we're doing the right thing. Hold on a minute. Let's run this baby. All right. It says 235. What are we not doing here? If I equals Elva. All right. I print data, which means I print my list, which is good. Then I print C. Is there something over here that I'm missing? No. Why am I not printing Elva? Is Elva not in the list? Elva has to be in the list. I don't believe this. What are we doing wrong here? Well, let's pick something we see in the list. There's Anna. Let's see what Anna has to tell us. Okay. Where did Elva go? Did I do something with Elva since the last time I ran this video? Interesting. Oh, well, I'll ponder it later. So now if I go I equal to Anna, I see that Anna appears in the 181st spot, and that I have 235 names. So let's confirm that by doing print len data. And we have 235 twice. Why do we have 235 this time? Because when you run len on a list, you get how many items in the list. And there are 235 items in this list. Okay? That might be the answer to the question. I think in the past when I ran this, the list was 500 something, so maybe I cut it down for some reason. I don't know. All right? So that is the key. We read in a file, but then we had it all in a string, but we used some string methods to create a list. And now you have, once you have a list, then you can iterate over it. And you can look at a whole bunch of different things in that list. So you're taking the data and you're actually using it and you're doing something with it, okay? All right, good. Two last little things real quick we're going to look at. All right. The first thing is just something I want you to see because I want to be complete. 1, 2, 3, and I think that's going to work. Okay, I have a file. It's called numbers.dat. I'm going to show it to you. Okay, numbers.dat, 12, 23, 34, down the line by line, okay? This is the way Python programmers usually deal with files, because most of the time when you're reading files, you can read them line by line, okay? So a lot of Python programmers will use the with as construct. That's what we call it. And basically with the with as, you're saving yourself a lot of time and you're saving yourself a lot of trouble. I'll walk through it. You say with, and then you do the open numbers.dat to read as f. So you're relating your file to the variable f. Then in the next line, you just set up a loop. And you say for line in f. You don't have to call it line. You could say for I in f. It's going to grab you, boom, the first line of the file. Okay? And then what I do is I print it out. I make it an integer first, because remember, you're reading in strings. Line is going to be a string. And then I make it an integer. You'll see why I deal with the integers in a second, because we're going to do something to it. Okay? So this saves a bunch of time. I'm going to run it first. And as you can see, 12, 23, 34, it basically takes, let's see, get that out of the way, get that out of the way, and look at that right there. Okay, so it's basically the file, and we just printed it out. Printed it out. All right, we printed it. So look at this construct. What's missing? There's a couple things missing, right? You don't see the read. The read is implicit in the for line. For line and F, boom, you read every line, line by line as you're going through. So you don't have to worry about doing a read. And what else is missing? The close. With a with as, when you're done with that file, when you hit a thing called the EOF or the end of file, you automatically close the file. So with as gives you the read because you're iterating and it assumes you want line by line by line. And then when you're done with it and you hit end of file, you close, boom, automatically. So it helps you do a lot. Now, if you want to read something character by character or in different chunks, that you don't want to use this. You want to use something else you can control. But in a lot of cases, you're going to take a file, gung, 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 and you're just going to read it line by line. This is what a lot of programmers will do. They'll use with as. You feel free to use what we started out with. Okay? And when you read, you read your slides and you learn a little bit more about pickling and stuff like that, you're going to realize in the future you're going to be dealing a lot with objects. And basically what you're going to, when you write objects to files, you do a thing called serialization. So you're going to be using whatever the serialization setup you're using is. But as far as just reading in a file of numbers, boom, 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 also a lot of times you're going to be reading Excel spreadsheets. So you're going to have a library where you could deal with Excel spreadsheets. I'm getting ahead of myself. With as, I just thought it was fair to show you because everybody uses it. And it would be, it'd be silly 4 months from now for you to see it in code and go, oh, I never saw that before, blah, blah, blah. Everybody uses this. All right, just so you know. All right, there's one last thing we're going to go over, and it's pretty important. So, and of course I'm giving you all this code at the end of the video, so you got no worries. The last thing we're going to cover is pretty important because it's output files, and you can also write to files. And what I'm going to do here is I'm going to create an output file called OF. If you look here, do I have it? No, I don't. I deleted it. Look at me being all prepared and stuff. You see right here in this directory, Python Data Science, Summer 2017, which is going by at breakneck speed. I can't believe it is June 19th already. The high schools are letting out, for God's sakes. It's incredible. Unit 3. All right, there's numbers. I don't see anything called outnum, yeah? So what I'm going to do out of whole cloth is I'm going to create a variable called OF for output file and assign it open outnums.dat. I'm just going to create a name, and I'm going to open it with a W, and the W is for writing, so I can write to it, okay? So now that variable, that's a file handle ready pointing to an output file. We'll be back there in a minute. So now I'm going to keep going with my with as. I'm going to open up numbers.dat as F, and then I'm going to iterate through that. So for line in F, first thing I get is a 12. First I'm going to print it. Then I'm going to create a variable called bump. And what bump does is it takes what I read in the file and it adds 1 to it. So it's going to take that 12, which is a string, it's going to make it an integer, and it's going to add 1. So that 12 is going to become 13. The variable 13 will be assigned the value, the variable bump will be assigned the value 13. Then what am I going to do? I'm going to write it. I'm going to write it to outnums. So I go of.write. But then remember, I'm dealing with an integer, and in sequential file I/O, we want strings. So I'm going to make string a bump, and then I'm going to feed it a new line so that it writes and looks the same as numbers.dat. All right? Then what happens? I go to the top of the loop. For line in F, grabs me 23. I print it. Then I create bump. Bump is assigned 23 plus 1, or 24. I write 24. I feed a new line. Go get the next one. You see? So outnums.dat is going to be the same as numbers.dat, but every number will be increased by 1. Okay? So let's run this and see what we get. All right, I'm looking pretty good. It printed, which is what we wanted because I have a print in the middle of it. Now let's go see if I have my out. I do. Look at that. I have outnums, which is great. I've now created a file, but there's a problem. What's the problem? Dun 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 dun. I look at outnums, and there's nothing. Bupkis. 0. What in the name of heaven happened there? All right, I'm going to tell you what happened. We did not close the file. All right? This is how your computer handles writing output files. When you write to an output file, you're not writing to the hard drive right away. You're writing to a little area of memory called the buffer. Okay? It's in RAM, in an area called the heap, blah, blah, blah. I digress. And that's what you're writing to. Okay? Until you close an output file, until you do the close, it does not get written to the hard drive. So when I did that open command, it said to the operating system, hey, I need a file called outnums.dat. And that's what we saw when we went to Windows Explorer. But none of what we had done had been written yet because that buffer was never written to the hard drive because we didn't close. This time, we're going to close, and we're going to see what happens, okay? Let's save. Let's rerun. Okay, like last time I ran, and I'm okay. This time I go, and I see outnums, but look at this. Now I've got something in there. I see 1 KB, and I see that we're okay. Let's take it and put it next to our guy. And as you can see, it's one more. 12 is 13, 34 is 35, 76 is 77. So we followed along with the logic, okay? And we created bump, which was one more than what was read in, and then we wrote it out. So this right here is numbers.dat. This right here is outnums.dat, okay? See it right there, outnums. And that's all right there. What is that, 7 lines? We created a new file. And we created a file with the same numbers as numbers.dat except increased by 1. Up and down the line, okay? The most important lesson out of this, always remember to close output files because that's what takes it from the buffer, boom, and puts it down in the actual file. If you don't do the close, you're not going to write to the actual file and you're not going to have it. Because now, if I wanted to, I don't know why you would, but if I wanted to come down tomorrow morning and grab outnums and add 1 to everything again, well, I could do that, okay? Because now it's in a file. Now it's in a durable store, okay? So that is basically how we deal with files. I can't imagine a grand finale for this is any great shakes, but let's give it a try anyway. All right. You know what? I'll take it. That's fine. And I'm sure it created outnums for me again, which it did. So you have outnums there. All right. I am going to take all of this code, and I am going to put it on Sakai for you. So you're going to have it to play with and tool around, and you have all of this stuff so you can tinker and do things for yourself and do a whole bunch of stuff. Again, like I said yesterday, I am not going to clobber you with announcements because there's another video coming. Actually, there's 2 more coming. There's another video coming on libraries and modularity. And after that, there's going to be yet another video coming as I redo Euler 6. And I redo it with all of the things that we're learning. Okay? It's funny. I am taping this Monday night. So we have not met yet. But I'm going to release this Tuesday night. So you will be seeing this after we had class. So hopefully class was good. I'm sure it was. And you got a lot out of it, and you learned a lot about the FizzBuzz, and you learned about a lot about the rainfall problem, and a whole bunch of things along those lines. Okay? I'm not going to remind you about class because you've already been there. But I will remind you July 11th, midterm project. All right? And be mindful of creating groups because you've got, maybe a week to create groups, and we need to get groups created so we can get rocking and rolling with the final project the minute the midterm is over, all right? All right, then I'm getting out of here. You be good, and hopefully the next couple of nights I'll see you with that 3rd Unit 3 video, all right? All right, be good. Bye.